This is a recording for the first lecture of additive manufacturing. I'll try to cover a lot of the introductory material that was covered in the first lecture that I posted on the first lecture. But this video will be split into two or three because I cannot have more than 10 to 12 slides in one video because that's all the what the system will let me do. So this is covering lecture one. So the course outline will consist of what are the typical engineering and additive manufacturing techniques that you can find in common literature and in the different industries across the world. Some of the concepts and common examples, and I will also discuss a little bit about the development of additive manufacturing technologies. We will talk about the additive manufacturing process chain. Then we will talk about additive manufacturing for polymers and composites. And then we will talk about metals and metal matrix composites. Then we will cover that with ceramics and ceramic matrix composites, applications, and some personalized product development. So, in order to understand this technology better, you need to understand what. So, this is a very applied class because we will talk not only about the technology but also the applications and what is the um, commercial potential, because that's where the biggest impact of additive manufacturing is, especially for developing and creating new products in the market, is where additive manufacturing is used. That's where it was started. But what has happened in the recent few years is how to not only develop a new product but also to rapidly manufacture the product for actual applications in the real world. For example, in the aerospace world by GE and people like Lockheed. So we will talk a lot about that. So from about 1990 to about 2005 or so, it kind of it was a middling kind of a technology, but after 2007 the technology just took off like anything, and now it is um, the total value is over $5 billion or so. This is according to the Waller's report, which is a very respected industry report that came out in 2015. And it is expected to reach almost $20 billion in the next couple of years. So you can see how fast things have been taking place. The number of 3D printers, I mean, everybody knows about 3D printers. The number of 3D printers has really taken off since 2010 or so. You may have heard about what is called um, the system for um, looking for funding for to develop a new technology for yourself. Have you heard about, I mean, you must have heard about what is called Kickstarter. So if you go look up Kickstarter, you can see that there are at least 100 to 150 technologies being promoted on Kickstarter trying to find money. If you look at the list of solicitations put out by the Department of Defense, in the small business innovative research and small technology transfer research, you can see that at any given solicitation cycle, there are at least 70 to 80 topics being promoted as, requesting for new ideas. So you can see the amount of interest and the amount of um, development that is taking place in this technology. So, according to Waller's reports, he thinks that it will cross $20 billion by 2020. And I believe that this is an underestimate. I believe that in the next 1 or 2 years, it'll be $20 billion plus. So, some of the action items I would like you to do is I would like you to go and look up GE technology reports. I would also like you to sign up for a daily newsletter from 3dprintingindustry.com. This is an industry website that you can get a, a daily newsletter about different technologies being developed in the field. Please look up this particular technology where GE is making turbine blades using 3D printing. Turbine blades by the thousands are being made by GE for their next generation Gen X engine. Also look up, there is a video on this particular website. You should look it up. And also please look up Waller's Associates and similar industry newsletters. There is a lot of information, and you as technologists and engineers and scientists, you should get excited by this technology. Talking about myself, I have been part of the additive manufacturing, 3D printing. We used to call it, when we started out, we used to call it either rapid prototyping or solid freeform fabrication. This was in the early 90s. That's when I started in this technology. And I have been part of many, many different technology developments in 3D printing and additive manufacturing. And I'm so amazed at the range and breadth of this technology and where it started out and where it is today. And I want you to get excited by this technology. I mean, don't think about this class alone, but as a scientist, as an engineer, as a technologist, you will be amazed at the capabilities of this technology, or broadly, this technology broadly known as additive manufacturing or 3D printing. So let me give a brief history of additive manufacturing. You may have read about it already, but just let me give it to you anyway. In 1987, actually this is a little dated. Actually, 3D printing started out, it's supposed to have started out in the early 60s or 70s itself. But they could not, the machines could not make what they wanted. But it started being capable of actually making parts in 1987 when a company called 3D Systems introduced stereolithography, and Ciba-Geigy, and I don't know if Ciba-Geigy is still existing as Ciba-Geigy, but they started creating new types of acrylate resins. And then in 1988, DuPont developed the stereolithography machine, and Loctite entered the stereolithography resin business till 1993, and then they gave up, and they must be kicking themselves now. Um, In 1990, um, Electro-Optical Systems Germany sold their first stereo selective laser sintering technique, and in 1991, um, three commercially available systems became available. First one is a company called Stratasys from Minnesota, and they are probably the company that sells the maximum number of 3D printers in the world, although they are not the best. But you must have seen a printer called MakerBot that is now owned by Stratasys. Then you had Cubital. Then there is a technique called laminated object manufacturing, which is no longer existing anymore. Then you had other techniques that came into being from University of Texas Austin. University of Texas Austin has really been at the forefront of what you would call solid freeform fabrication, and they have run a yearly 3D printing conference. It used to be called Solid Freeform Fabrication Conference. Now it is called International um, Additive Manufacturing Conference every August on the University of Texas Austin campus. And there is a person called David Burrell. And in fact, these three people, David Burrell, Harry Marcus, and Joe Beeman, these three names are really famous, and they started from their technology called selective laser sintering. In fact, many of the new technologies came as a result of the selective laser sintering technique. And their students created DTM, and DTM was taken over by 3D Systems around uh, 2000 or so, and now 3D Systems and Stratasys are two largest additive manufacturing equipment manufacturers in the world. There are other techniques also being developed all over the place. Um, there are other techniques being developed, but those are all very minor. But the biggest 3D printing equipment manufacturers are first 3D Systems and second Stratasys. The rest of them are all very minor. So they have almost um, 30-40% share of the market. 1996. So when these machines came into being, you will be surprised. The first one, the first machine cost even the smallest machine cost about $150,000. The computer that was used was made by Sun Spark Systems, so it had to be a standalone system, and that used to cost almost $100,000. In 1996, a company called Z Corp that came from that is an offshoot of a technology developed at MIT based on powder systems, and they were the first sub $50,000 machine. And then there were other machines came into being, but now they have not yet been uh, completely made. Of course, there are new companies called Optomech. We are in the process. Oklahoma State is in the process of buying our first major metal additive manufacturing machine. Of course, it costs about $350,000, which is pretty expensive. So, anyway, there are many such technologies being developed. So, this was the kind of cost you would find in those days. Now you can walk into a company like Walmart or uh, one of these printer companies. I mean, like, office supplies companies, Office Max. I don't know if Office Max is still existing, but if they do, you can get one of these machines for less than $300. In fact, when we started when I started in the 1990s, our goal was to make a printer for under $99 and sell them in uh, any of these office supply companies. And I think that dream is really coming true nowadays. So, if you looked at the Wallace Associates bar charts, you will see that around 2007 2008, the bar chart just took off. Why did that happen? Because around 2007 to 2008 to 2010 or so, all the patents from 3D systems, Stratasys, and patents developed by MIT, they started expiring. So then there were a lot of small companies that came up with under $500 printers. There is a company called Fab at Home, and in fact, MakerBot, when they came, what they told us was that we will give you a complete package of parts. You just put the whole thing together. It will cost you $250 to $500 at the most. But Stratasys was smart. They had a lot of money built up, cash built up. So what did they do? They went and took over MakerBot. And the price of this printer went back up to between $2,500 to $5,000. So Stratasys also bought up several patents and filed continuation patents. So unfortunately, the whole technology that was based on innovation started being put on the shelf by Stratasys. But the other patents have expired and they have really not been able to stop this technology from being developed. So I would say that there is what I would call innovation overload. There is an innovation a minute in 3D printing, and that's really exciting for somebody like me. And I want you to get the same thing. So, how do you define rapid prototyping and how do you express these ideas in rapid prototyping? So, let me stop here and I will pick up in the next slide.